Okay. First of all, we're starting in a stoichiometry here, and I think we might have started this before you got sick and left class. But it starts with just basic equation balancing. So I'm going to review that. The worksheets that we're going to be doing, I've posted on the website. One of them is called green level questions. The other one is called brown level questions here. And I'm going to kind of have to do this a little quickly. I'll probably be able to explain it better once you get back. But first of all, if you had an equation like this, could we balance it? All right. I think that you could probably do this. Let me go ahead and do it real quick. You're going to have Sn, which is 10. You're going to have oxygen and carbon. You have Sn, oxygen and carbon. All right. So remember, when you balance, you're going to start with ones up here. All right. You have 110. You got 2 oxygens. You've got 1 carbon. 110, 1 oxygen, 1 carbon. All right. Take a look at these two here. Are they balanced? No. You need more oxygen over here. So I can do that by doing that, doing that. And the thing is, that also means I've got 2 carbons over there. So I need to increase my carbons over here. Okay, 1, 2, 2, 1, 2, 2. So I'm balanced. Okay, so so we've done the equation balancing. So let me get rid of these lines here. Okay. So, but what exactly do these coefficients mean? Okay. What this means on a molecular level is if you had one of these units, you would have to pair it up with 2 of these guys in order to make 1 of these guys and 2 of those guys there. Okay? And so, but I mean, obviously atoms are really, really, really small, so it's not practical to say that, you know, if I had some tin oxide, I could pull out literally 1 of those, and I could take 2 individual carbon atoms and kind of put them together to get this reaction to occur. Whenever we're dealing with chemicals, we're dealing with, you know, billions and billions of molecules that were atoms. All right. For instance, this is a little table salt here, you know, NaCl. You've got literally trillions of little atoms in there. All right. So, but what this means is it establishes a ratio. It says for every one of these, it's gonna require that you have 2 carbons, and you will make 1 of those and 2 of those. All right. And in chemistry, like, it's impractical to talk about amounts in terms of individual atoms. We need to have something that's a little bit more practical. All right. And that thing's called a mole. All right. So the next part of the video is going to talk about what exactly that is. Okay. So the best way to describe what a mole is to compare it to something that you're already pretty familiar with, which is the word dozen. All right. So obviously, if I said that you have a dozen eggs, you should realize that that means that you've got 12 eggs. All right. The literal meaning of the word dozen means that you just have 12 of something. All right. But the thing is, it expresses quantity, but it doesn't say of what. You can have a dozen eggs. That means you have 12 eggs. You could have a dozen grains of sand. That just means you have 12 grains of sand. You could have a dozen elephants. That would be 12 elephants. All right. So just because you say dozen, it doesn't say anything about how much that thing weighs. All right. All it does is express a quantity. How many things are there? All right. Well, the thing with chemistry is you have this concept called a mole. All right. And a mole works the same way as the word dozen. When you have a mole of something, that just means that you have this special number here. It's 6.02 times 10 to the 23rd particles of that something. All right. And the reason that you use the term particles is that because just like dozen, the thing that you have that many of can be different depending on the substance that you're talking about. So I'll give you a really couple of quick examples. All right. If you had 1 mole of H2O, all right, what would that mean? Okay. Well, first you got to ask yourself, what is water made of? Okay. H2O is This is a covalent compound. If you look at the periodic table, the hydrogen is one of the pink atoms, oxygen is one of the pink elements. So when they combine, they make water molecules, all right? So 1 mole of water would be 6.02 times 10 to the 23rd molecules. Okay? If you had, for example, my ring right here is palladium, all right? That means when you have a pure metal, it's not made of molecules. It's made up of individual atoms of whatever that element is. So this ring is made up of palladium atoms, all right? So if you had 1 mole of PD, all right, well, it would mean you got 6.02 times 10 to the 23rd of something. The question is, what is that something? Okay, and so if you look here, what is the smallest unit of H2O? It's an H2O molecule. What is the smallest unit of palladium, which is PD? It's a palladium atom. Okay, so again, all it does is express quantity. It tells you how many of them you have. All right. The last one is a little bit tougher to explain. Let me erase this.